Hello, this is the solutions video for homework 2.5b. We're on page 139. We're going to run through these 6 problems. Number 11, so we have sine x plus 2 cosine 2y equals 1. Going to take the derivative with respect to x of that. Derivative of sine is cosine. The derivative of cosine is minus sine, so it would be minus 2 sine 2y times the derivative of 2y. So that'd be 2. All right, derivative of 2y is 2 times dy dx. Okay, because the derivative of y with respect to x is dy dx, and that's equal to 0. Derivative of 1 is 0. Let's collect the dy dx term on the left, so I'm going to multiply those two together, so I'd have minus 4 sine 2y dy dx. Move cosine x to the right, so that would make it negative. And then dividing by negative 4 sine 2y, our final answer, we would have negative cosine x over negative 4 sine 2y. The negatives will cancel, and we end up with this, cosine x over 4 sine 2y. Now you can't change that into 1/4 cotangent because the angle's not the same. We have an x and a 2y there, so don't make that mistake. That's the best you can do. All right, 13, we have sine x is equal to x times 1 plus tangent y. I went ahead and distributed the x and made it x plus x tangent y. You could have taken the derivative like this with the product rule. I just thought it was a little easier doing it this way. So the derivative with respect to x of sine x is cosine x. Derivative of x is 1. And then we have a product rule here. The first x times the derivative of tangent y, that'd be secant squared y times dy dx. Derivative of y is dy dx. Plus the second tangent y times the derivative of x, which is just 1. Now I'm just going to leave the dy dx term over on the right, since it's already there, and move the 1 and the tangent y to the left. So we have to make those two negative, so I'd have cosine x minus 1 minus tangent y is equal to x secant squared y dy dx. And then solving for dy dx, I'm going to bring that x secant squared y underneath. And that would leave me with this. All right, looks fancy, but not too bad. I hope you didn't think that's too bad. All right, let's move on to number 15. So 15, we have y is equal to sine xy. All right, we're going to take the derivative with respect to x. So the derivative of y is dy dx. Derivative of sine xy would be cosine xy, and then we have to do the derivative of xy. So that's times the first x times the derivative of y dy dx. First times the derivative of the second, plus the second y times the derivative of x, which is 1. All right, let's distribute now. So I have x cosine xy, so I'm multiplying this term by this term, dy dx, plus y cosine xy. So I'm multiplying the cosine xy by both of these terms. Now I'm going to bring the dy dx term on the right over to the left. So I have dy dx minus x cosine xy dy dx equals y cosine xy. Let's factor out a dy dx, and I'd have 1. Remember, we're factoring out a dy dx. Out of dy dx, it's 1. That's such a common mistake. Minus x cosine xy is equal to y cosine xy. Hey, we're almost done here. Dy dx. We're going to bring that 1 minus x cosine xy underneath. So we have y cosine xy over 1 minus x cosine xy. All right, and that does the trick. Okay, so not a super easy one, but not impossible by any means. All right, and then number 16, we have x is equal to secant 1 over y. So let's take the derivative with respect to x. So that'd be 1 is equal to secant 1 over y tangent 1 over y. Remember, the derivative of secant is secant times tangent. And then what's the derivative of 1 over y? Let's do this over here. So that's the same as y to the minus 1, right? And the derivative of that would be minus y to the minus 2 times dy dx. So times minus y to the minus 2 dy dx. Okay, so let's see. Let's clean this up a little bit. We've got 1 is equal to secant 1 over y tangent 1 over y over negative y squared. I'm going to go ahead and bring that downstairs. And then the dy dx would be on top. Okay, so what I'm going to do, I'll go ahead and show this the long way. So dy dx, then we're going to bring this entire fraction underneath. 1 over secant 1 over y tangent 1 over y over negative y squared. But 1 over a fraction just flips the fraction, right? So dy dx is going to be negative y squared over secant 1 over y tangent 1 over y. This one looks familiar, so I probably work this one for students almost every year. And it's probably the issue is more towards the end that will get you. But there you go. That'll do the trick on 16. Okay, 17 and 19 coming up. Right, 17, we have xy equals 4. And we're evaluating that at -4, -1. So let's take the derivative with respect to x of that. So we've got a product rule. The first, x times the derivative of y, dy dx, plus the second, y times the derivative of x, which is 1, is equal to the derivative of 4 is 0. So we have x dy dx is equal to -y. So dy dx is equal to -y over x. So at -4, -1, that would be -1 over -4, which would be -1/4. So that's +1 over -4, -1/4. All right, and then number 19. Looks like to me it's going to take a little more room. Okay, we have y squared is equal to x squared minus 9 over x squared plus 9. And we got to evaluate at the point 3, 0. There's a couple different ways you could do this. You could bring that x squared plus 9 over here, multiply it by the y squared, and not have to do the quotient rule. Or you could do it with the quotient rule. And, you know, either way is kind of a mess, but I typically like to avoid the quotient rule. So I'm going to try it. I'm going to multiply both sides by x squared plus 9. So we'd have y squared times x squared plus 9 is equal to x squared minus 9. So that's x squared y squared plus 9y squared is equal to x squared minus 9. And now I'm going to ddx that. So if you did it, since you could totally do this with the quotient rule, bottom times derivative of the top minus top times derivative of the bottom all over the bottom squared, because you're just plugging a number in. I just think our final answer might be, with this method, our answer is going to be a little more simplified. So let's see what happens here. Okay, we've got a product rule. It's the first, x squared times the derivative of y squared. That's going to be 2y dy dx, plus the second, y squared times the derivative of the first, 2x, plus 18y dy dx, and on the right side it's just 2x. So let's collect here. We've got 2x squared y. I'm just putting the x first and the 2 first, and then the x, dy dx, plus 18y dy dx equals 2x minus 2xy squared. Okay, factor out a dy dx, and I've got 2x squared y plus 18y is equal to 2x minus 2xy squared. So dy dx is equal to 2x minus 2xy squared over 2x squared y plus 18y. We could actually factor out a 2 out of all terms, and you'd have x minus xy squared over x squared y plus 9y. And then at 3, 0, I would have 3 minus 0, okay, because the y term is 0, over 0 plus 0. That's 3 over 0. So it's actually, the answer is undefined. All right, so if you chose to go quotient rule, you're going to get a version of this. It would be the same as this. It's just going to be far less simplified. The bottom term will be squared. It'll be a big mess, but it still should give you a 0 on the bottom when you plug in. All right, so that'll do it for this video, and I will talk to you next lecture.